Okay, in the past several videos, I've gone through a series of steps using the illustration provided by Heck and colleagues in their book, Multi-Level and Longitudinal Modeling with IBM SPSS. And in Chapter 3, they go through a process of running various multi-level models aimed at predicting variation in students' levels of math achievement. They incorporated a level 1 predictor, which was socioeconomic status, and they essentially went through a series of steps incorporating various level 2 predictors of variation in school level intercepts and also school level slopes. So in other words, they were allowing SES, the relationship between SES and math achievement, to vary across schools. And so in the previous video, my last video, I ran a model that incorporated cross-level interactions. And you can see that essentially what we have are three interaction terms. So you can see first of all, we had SES, which was the level 1 predictor, and this was essentially the regression coefficient. The level 2 predictor of variation in intercepts incorporated was this variable right here. This was one of them. This was the average SES for the students within the schools, so the average school level SES, I guess you could say. We also have another level 2 predictor, which was the proportion of students within a school intending to go to a four-year college. And then we also had another level 2 predictor, which was called public. It was coded 0 for private school, 1 for public school. And then we tested a cross-level interactions between each of these level 2 predictor variables and the level 1 predictor variable. And what we found was that only one of those interactions was statistically significant. That was the interaction between the public variable and SES. So in the previous video, I essentially provided an example of a plot of simple slopes by group. And so you can see that these are the slopes of the relationships between SES, or student level of SES, and math achievement. So by type of school, whether it be a public school or a private school. So you can see that the relationship between student SES and math achievement was a little bit more pronounced in the private schools as opposed to the public schools. Not a whole lot more, but it looks like it is a little bit more pronounced in the private schools. So you may be wondering how I plotted this, and basically what I did was I created calculator recently, which is basically allowing you to plot this out. So in the little yellow boxes, this is information that you will provide, and then in the orange boxes will give you predicted values on Y, which is at level 1, which is the predicted value of math achievement. That essentially varies depending on whether the student is in a private school or public school, and also the individual student's level of SES. You'll also notice that we have the plot right here. So as you type in the information in these yellow boxes, then you'll get the predicted values, the actual simple slopes and intercepts, and then also the actual plot right here. So you don't need to mess with anything over here in terms of the orange boxes. You just need to feed information into the yellow boxes. So how did I do this? Basically just utilize the calculator that I just plotting simple slopes with continuous IVs and dummy coded categorical moderator for HLM. And the actual title of the calculator is Graphing Simple Slopes in HLM with Continuous X and Dummy Z. So to kind of walk you through the steps, what I did was, first of all, I needed to have, let me get rid of that. I needed to have the mean and standard deviation for the level 1 predictor, so basically to do that, I just went into SPSS, went to descriptives. I clicked SES over to this box right here. The defaults include mean and standard deviation. So when I clicked on OK, you'll see that this was the mean standard deviation for the variables. So I just typed those in, and I included a little, I could type in the name right here. And then for public, I just gave it the code 0 and 1, and then I could name these in terms of the categories. So I just typed in, private and public here, and that's basically all that happened. Over here, these are the regression parameters from the multi-level model. So all I did was, you'll see I have the intercept, which is 56.505 or 506. And so that's it right there. So, 56.506. There it is. The X variable I treat as the focal predictor. And so all I did was I just went to the SES and obtained the regression coefficient from that, which is 3.765, or 3.764, I guess you could say, and typed it in there. The moderator variable was the level 2, and so I went to public, and that's the coefficient. So I just typed in negative 0.122, and so that's what I typed in right here. And then the interaction term from the analysis is coming from this box right here, so negative 0.667. So that's where it's typed in right here. So when you do that, you end up with the predicted values on y being generated, and then this is a plot of those simple slopes by type of school.